Hey, this is Mr. Janes. In this video, we'll be talking about the properties of quadrilaterals. In order to do that, we'll be using various paper foldings right here to discover and then write down some of the properties about sides, angles, diagonals of these quadrilaterals. One thing to keep in mind, whenever you see two triangles that are made of the same color paper, for example, these two purple triangles, you can assume that those triangles are congruent, that they have the same side lengths and the same angle measures. In order to take good notes, we'll need to have our note sheet out. So, take out the front page of your note sheet and go to the bottom where we will start with isosceles triangles, right here. As I'm doing things with the folded paper, please make sure you are marking the diagram here. For example, any markings of angles or sides that I do, any congruence or parallel markings, please make sure you mark those as well here. We'll come back at the end to make sure that you have them, but please make sure to do that as I'm marking my folded paper. Let's get started with the isosceles triangle. Here we have an isosceles triangle created from two right triangles. Two right triangles. Now, we know by definition that an isosceles triangle has two congruent sides, these two right here. Again, they're congruent because, one, by definition, but two, because this is a reflection onto itself, right? A reflection across this line right here. As a result, there are another pair of angles that are also congruent. This angle here and this angle here, we call them base angles, are congruent. Again, we can see that because they can reflect onto each other. Therefore, anytime you have a isosceles triangle, you can notice that the angles across from the congruent sides, such as this angle right here and this angle right here, must be congruent. Another way to look at it is to take your isosceles triangle like this, draw a line of symmetry down the middle between those two congruent sides, and then notice that these two angles must be congruent by symmetry. And here's how I've sketched that out in my notes. If you need to pause here to copy this down, you can. Next, we can look at our quadrilaterals using our folded paper. Again, turn to the next page of your note sheet so you can copy down some important information. And we're going to start down here with the parallelogram. Here's a parallelogram made out of folded paper. Now, as you can see, it's made up of two different triangles, these yellow triangles here and these green darker triangles here. Now, you might think there's a reflection going on, but actually there's no good way to reflect a parallelogram. Instead, a parallelogram has rotational symmetry, 180 degrees. Now, this can help us figure out some of the properties. For example, take a look at this top edge and this bottom edge. If I just rotate this 180 degrees, it's clear that those sides are congruent by rotational symmetry. In addition, these green edges here, if I rotate this, are also congruent by rotational symmetry. So I'll mark those as well. What else? Well, every part of this yellow triangle is congruent to every part of this yellow triangle. So for example, this side here, if I were to rotate that around, is congruent to this side up here. So those I will mark. And these other diagonals as well. Again, if I rotated those, it would be congruent to each other. So these diagonals, in essence, bisect each other. They cut each other in half. They're not all the same, but this half is congruent to this half, and this half of the diagonal is congruent to this half. Pretty cool. Some of the angles are also congruent. For example, this angle here is congruent to that angle up there. Those are both congruent to each other. Or this angle here is congruent to this angle over here. So those are also congruent to each other. And we can fill in the angles on the other diagonal as well. Two there, two there, I guess 4 there, and 4 there. We could also work with a slightly simpler parallelogram that's created by a rotation again, but this time of just any two triangles. And notice that the angles that are opposite each other, so if I take that one and rotate it, will be congruent. So these two angles must be congruent. And these angles as a whole, this whole angle there, and this whole angle over here, must be congruent to each other. This is how I've marked my diagram when it comes to parallelograms. Next, let's talk about rectangles. Now we know that by definition, rectangles are quadrilaterals with 4 right angles. And so I'll mark those in here to begin with. 4 right angles. Okay? But they've got some other properties too that we can tell from here. Now, when it came to the parallelogram, we knew that the diagonals bisected each other, which means that they cut each other in half. But it's a little better in this one. If I look at this one diagonal to start, I notice that because this rectangle has reflective symmetry, which means I could fold it down onto itself like this, this will also be the same length. It'll be congruent. And since I could also reflect it this way, onto itself like that, okay, these will also be congruent. So all 4 of the diagonals are congruent. In fact, in a rectangle, the diagonals are congruent to each other. In addition, these 2 sides are congruent, again, because there's that reflective symmetry onto itself. And these opposite sides will be congruent, again, because you have that reflective symmetry onto itself. We can also notice that because, again, of this reflection, this angle right here, let's see if I can reflect this over, will be the same as this angle right here. They'll be congruent. And if I reflect it up, okay, across this kind of center line here, we know that these will also be congruent. Okay? And lastly, these angles are also congruent because of the same reflection. Let's make sure we have that down in our notes. And here's my notes. Remember, the most important properties here are 1, that all the diagonals are congruent, and 2, that there are 4 right angles in a rectangle. Next, let's look at a rhombus. I have a rhombus here that is made up of 4 right triangles. Now, because all 4 of these triangles are exactly the same, we know that all the sides of a rhombus will also be congruent, exactly the same length. What else can we know? Well, just like in a parallelogram, the diagonals bisect each other, right? Again, because we've got this kind of reflection going in this direction and also a reflection going in that direction. Okay? What else, though? We said these are all right triangles, so in fact, in the center of the diagonals, they are perpendicular. They intersect at that 90-degree angle. What else can we do? Well, since this is a reflection, if I look at this angle here and I reflect it in this manner, it'll be the same as this angle here. Or if I take both of those and reflect it across the center this way, I can tell these will also be congruent. Similarly, these 2 angles, or all 4 of these angles, are congruent. So in a way, the diagonals cut each of these angles in half. The diagonals bisect each of the angles. Here are my notes for rhombus. The important things to remember are 1, the diagonals are perpendicular. You can see that right here. The diagonals are perpendicular. 2, the diagonals bisect each of the angles. See how they cut each of the angles in half. They're congruent. And thirdly, that although the diagonals are not the same, the diagonals are bisected, so they're cut in half. Each of them are cut each other in half. Here we've got a square. Now a square can be made up of 4 isosceles right triangles. Now what does that mean? Well, first off, we know in a square that all the sides are the same. And that makes sense because I can rotate this 90 degrees and I will have the same square, the rotational symmetry. Also, each corner, each vertex, each angle, is a right angle, 90 degrees. We can do a little better than that. Since these are all the same triangle, they're all congruent, all the diagonals will also be congruent to each other. And since these are isosceles right triangles, we know that the angle in the middle is a right angle all the way around. But one other thing. Again, since these are all the same triangle, I have this kind of level of symmetry in this direction, which means that these 2 angles, here and here, will be the same. In fact, they'll be the same all the way around. The diagonals cut these angles in half. They bisect them. And so if each of these angles is a right angle, 90 degrees, think about what will the measure of each of these angles be? Well, they'll be 45 each. That will happen in every single square. 45-degree angles created by those diagonals bisecting, cutting those in half. And here's my illustration of a square. Now it's got all the properties of a rectangle and all the properties of a rhombus because a square is both a rectangle and a rhombus. But let me put in that one thing we talked about at the end, where those are always those 45-degree angles because they are in fact bisected by the diagonals. Each of those angles is bisected by the diagonals. Let's go on to kites. Now a kite is made up of two right triangles that have been reflected over this line of symmetry right here. Now what does that do for us? Well, it means that these two sides will be congruent because that's a reflection. And it also means that these sides will be congruent because that's a reflection, but they won't be congruent to each other because, again, a kite doesn't have all congruent sides. That would be a rhombus. What else? Well, since these are all right triangles, the diagonals intersect at a 90-degree angle. The diagonals are perpendicular to each other. Well, because of this reflection, this line right here will be congruent to this line right here as well. So there's that. What about the angles? Well, we can fill in a little bit of this. This angle will be congruent to this angle, again, because you have this line of reflection kind of flipping it over there. This angle is congruent to that angle. This angle, you might think it's congruent to this one because they are adjacent, but again, using that reflection, we can see that it's congruent to this angle here, and this angle here will be congruent to this angle here, again, because of that reflection across that line of symmetry right down the middle. And here's what I put into my notes. Again, one of the most important things to remember about the kite is that it does have this line of reflection there, which means everything in this half will be congruent to everything in this half because of that symmetry. And also, it has that 90-degree angle created by those perpendicular diagonals. What about trapezoids? Well, with any old trapezoid, we know that we've got one pair of parallel sides, but past that, what else do we have? Not much. I mean, there's not much symmetry I can do here. It doesn't have any sort of reflective symmetry anyway. It doesn't have any sort of rotational symmetry, except for, I guess, 360 degrees, or the identity. So there's not much we can do with a plain old trapezoid. So in my notes, I've just simply marked that the bases are congruent to each other. I suppose you could say that these kind of consecutive angles here and here will sum up to 180 degrees. Again, that's because if you think about having some parallel lines here and transversal, these are same side interior angles, so they're going to add to 180. Okay, but that's really it. That's really it. Unless we look at an isosceles trapezoid. So let's say goodbye to the plain old trapezoid. Let's throw in a couple of isosceles trapezoids here. We'll start with this more basic one at the bottom. Now, an isosceles trapezoid has that one pair of parallel sides, but in addition, it's got these two sides are congruent to each other. One pair of congruent sides. As a result, it gains the symmetry, this reflective symmetry like this, which means that these base angles will be congruent to each other, and these base angles on the other base will be congruent to each other, right? That's what we can say about a trapezoid, or sorry, an isosceles trapezoid. We can also say a little bit more if we look at the diagonals. In the diagonals of an isosceles trapezoid, we have these two triangles that are congruent to each other, they're both red. Now that means that the diagonals, those are congruent, and these are congruent. So in fact, in an isosceles trapezoid, we have congruent diagonals, kind of like what we had in a rectangle, except they're not all congruent, just these two are, and those two parts are. Similarly, these angles will be congruent. We can have congruent angles here. We can have congruent angles here, 1, 2, 3, 1, 2, 3, and here as well, 1, 2, 3, 4, 1, 2, 3, 4. Again, all because of this reflective symmetry. All of the angles and sides on this half will be congruent to all the sides on this half because of that reflection. And so here are the notes that I have taken for isosceles trapezoids. Again, they have a little more than a regular trapezoid. I hope this video has helped you see some of the properties of quadrilaterals through reflections, rotations, and other kinds of symmetry. A little bit easier than if you just had to memorize them plainly. So hopefully this paper folding exercise has helped us a little bit. If you need to see anything again, be sure to go back, rewind, pause, and think about where all these properties come from a little more deeply. See you next class.